solve the general math questions from chapter 16.1, the first 5 problems. Let's start with number 1. We can see that the hypotenuse of a right angled triangle is 25 centimeter. First, we shall draw the triangle so that it's easier to understand. This is the right angle. We shall name the triangle A, B, and C. The hypotenuse, meaning side AC, being 25 centimeter. And next, it is written that one side AB is 3 by 4th of the other side BC. Now, if we consider side BC as x, we can see that side AB will be 3 by 4th of x. Now, all the sides have been named properly. We know that in a right angled triangle, the summation of other two sides, square on the other two sides, is equal to the square on the hypotenuse. So, the first we shall write the Pythagoras theorem. AC square equals AB square plus BC square. Or we can write that AC square, we'll write the length 25 centimeter square equals AB square 3 by 4x square plus, as BC is x, x square. Or 25 square 625 equals, we'll give the square on both numerator and denominator. So it will be 9x square by 16 plus x square. Now we will add x square plus 9x square by 16. Nine x square plus this denominator will be multiplied by the numerator. So it will be 16x square. Or 625 equals 25x square by 16. Or we can say that this denominator, which is in division in this side, will go in multiplication. So 625 into 16 equals 25x. Or now we will calculate this part. We can see that this part equals 1/10,000 equals 25x square. Or 25x square, this 25 will come in division in this part. So 400 equals x square. So we can see that x will be root over of 400. As the square will be square root on this part, so it will result in 20. Therefore, we can see that the side x of side BC is equals to 20 centimeter. Similarly, as we can see here, if x is 20 centimeter, then the side AB will be 3 by 4 of x, which is equals 15 centimeter. Now, they have asked for the both sides in here. We've got one side it's BC. BC as 20 centimeter and the side AB as 15 centimeter. These both are the results of the first question. I'll erase this board now. Moving on to the second problem. We can imagine that a ladder with height 20 meters stands vertically against a wall. We'll draw the wall. Let us assume that this, from A to B, is the wall. Now we will imagine a ladder equal size to length AB stands here. This is the wall and this is the ladder. Both are of which? 20 meter. We can see that the ladder and both the wall are 20 meter, not only one. Now they have said how much further should the ladder be lowered so that the upper end descends 40 meters. Let us imagine that this ladder is descended. We can see the ladder is this. So if we descend it like this, so how much will be descended in this part so that 4 meter gap is present here. The descended ladder being this, as this is A and B. Since the previous part was 20 centimeter, it has descended 4 meter here. 4 meter, but the previous whole part was 20 meter. And as the first line of the question has depicted, also the hypotenuse, being the ladder, is also 20 meter. So, if this is 20 meter, it has descended 4 meter, and the whole length used to be 20 meter. We can assume that from point A to point B, it will be 20 minus 4 equals to 16 meter. So, part AB is 16 meter. Do you have any problems to understand? If you have them, you can write them in the comment section below. Now, coming back here, we need to find the length BC. If the ladder descends 4 meter, how far will it go in the base? So we need to find BC. Let BC be x. Now, stating the Pythagoras theorem, I'll short it for PT. AC square equals to AB square plus BC square, or 20 square equals to AB square being 16 centimeter plus BC square being x. Or we can write 400 equals to 256 plus x squared. The 256 will come in minus in here, or we can write that x squared equals 400 minus 256 being 144, or x, the square here will come over root in here. So x being root over 144 is equal to 12 meter. So x, we can find the length x, which is BC, as 12 meter. This is the answer. If you have any problems further, write it in the comment section below. Moving on to the third problem. Problem number 3. The perimeter of an isosceles triangle is 16 centimeter. First, we shall draw the isosceles triangle. An isosceles triangle being two sides of the triangle equal. So, if we draw the triangle let me finish that again. If the triangle being A, B and C, the sides AB and AC will be similar or equal. So AB is equal to AC. This is an isosceles triangle. So the perimeter AB plus BC plus AC equals to 16 centimeter. AB plus BC plus AC equals to 16 centimeter or meter. If the length of equal sides is 5 by 4 of base, the base being side BC. Now, for the casualty of running the calculations, we will write side BC as x. So, if one equal side is equal to 5 by 6 of x, we can write side AB equal 5 by 6 of x. Similarly, in this case, since both of them are equal. The perimeter is given and all three sides have been calculated with a variable. So we can write in this case, similarly we will form an equation as we have in the first two maths. 5 by 6 plus 5 by 6 for both the equal sides plus x for the base side equals 16 since the perimeter is 16. Or we will add the three fractions. 6. We will take the common denominators. 5x plus 5x. And in his case, 6 will be multiplied to x plus 6x equals 16. Or 10x plus 16x equals 16x by 6 equals 16. Or this 6 which is here will come, which is in the division part, will come to multiplication in this part. So we can say that 16 into 6 equals 96. So 16x equals 96. So x, the 16 will come in division on this part, equals 6. So we can say the side BC is equals to 6. Since x equals to 6, so 5x by 6 equals to 5 by 6 into x being 6. 6 are diminished and 5 is remaining. Similarly, the other side will also be 5. Therefore, we can say that side AB is 5, side BC is also 5 and side AC is 6. All of these add up to 16.